Okay, so today I'm trying to use this technology so you can see what I'm doing here. So forgive me, I try to do it on my face and then it won't toggle back and forth. So anyway, technology. So take a look. We're going to be looking at cube roots and then using roots to solve equations this week. So for cube roots, it's quite simple, like we were doing. You have your radical symbol. If you can see that. There's your radical symbol. Is that upside down? I'm trying to get you to see it the right way around. Okay, well, it's going to have to, for both of us, it's going to have to be like this. Okay, so our radical symbol, our index, for a cube root, our index says 3. And then our radicand would hopefully be something that is a cube root. So what we're looking for is those triplets, right? So we're looking for 2 times 2 times 2. I know that 8 is made up of a cube, 2 cubed, right? And so therefore the cube root of 8 is 2, equals 2. Okay, that is just a simple cube root. You're going to have some work that's going to be like this. So some ones we see a lot. So this is like just training your brain to see the cube, what number that will be multiplied by itself 3 times to get me to 27. So hopefully you already have a sense of that cube, which is 3 times 3 times 3. Because 3 times 3 is 9, times 3 equals 27, and therefore the cube root of 27 is 3. Okay, so you're going to be looking at those cube roots. You're also going to be encountering the squares and cubes in, particularly the cubes, the cube root of a fraction. So the cube root of 1/8, for example. What is the cube root of 8? 1/8. So we're looking for a number, which in this case is going to be a fraction. Well, what's the cube root of, so what's the cube root of 1? That equals 1, right? Because 1 times 1 times 1 equals 3. That's cube root of 1. And then what about the cube root of 8, which we also know now, hopefully you were watching, 2 times 2 times 2 times 2, which would be the cube root of 8. So in the end, if you go back to my original question here, my original problem is, what is the cube root of 1/8? Well, the cube root of 1/8 is 1/2 times 1/2 times 1/2, right? See that? So if you think about it here, 1/2 times 1/2 times 1/2, right? Because 2 times 2 is 4, times 2 is 8. 1 times 1 is 1, times 1 is 1. So in my final answer here, the cube root of 1/8 equals 1/2. Okay, so that's when you counter those. Let's try another one. What about the cube root of 27 125ths? Well, hopefully you know your cubes, and you can already see that the cube root of 27 over the cube root of 125, that's a little 3 there, the cube root of 125. So what's the cube root of 27? Well, hopefully you've got it and you're already seeing it as the cube root of 27. What number times itself 3 times is 3, because 3 times 3 Oh my gosh, you're so, this is interesting. There we go. Sideways resolution. I don't know how to make it so that this can show that and that just off. Adjust it a little bit. No, that did not help me. Technology. There we go. The cube root of 27 is 3. And then the cube root of 125 is 5. Because 5 times 5 is 25 times another 5, right? Is 5. So in the end, if I'm looking back at it, the cube root of 27 over 125 equals 3/5. See that? That'd be a better way to do this. All right. So that's a little bit about the cubes and cube roots, and hopefully you can watch me as I do that. And you can see how we did that. So let me dial it back and just start with a simpler one. Let's see where. Is that edge? Or let's say we were looking at the square root of 4 16ths. Right? Well, I know you can. Let me do something else. Let me do the square root of 4 9ths. Okay, there, because I know you're already like, oh, you can reduce that fraction. Yes, you can. So here we are, the square root. So our index is 2, because remember, it doesn't, if it's not there, we know we're looking for a square. Yeah? And so what we think about is, not equals yet, we're thinking about, what's the square root of 4 over the square root of 9? Yeah? So we have perfect squares here. See that? And so the square root of 4 is 2, and the square root of 9 is 3. So our final answer for the square root of 4 9ths equals 2/3, right? Because you see that you have 2 times 2 is 4, and 3 times 3 is 9. So we're using what we know about squares, but now we're using it in fractional form, okay? And so that's what we do when we have fractions in our square. We're looking for a square root. I'll try another one like that. This is our square root, not a cube root, because the index is not there, so it's technically an index of 2, where I'm looking for 2 numbers, yeah, 2 factors that are exactly the same. So I'm looking for a square, a perfect square. And so let's try this one, which is, let's do 16 over 49. Okay, hopefully you can already see the squares in it. And then you're just going to, as a process, go, I'm looking for the square root of 16 over the square root of 49. Yep. And hopefully you already know your squares, so you know what 2 numbers that are the same multiplied together give me 16. 2 factors that are identical that give me 16, my squares. Well, hopefully you can already know that 16, that's 4 times 4. So, because 4 squared is 16. What number squared gives me 49? Well, hopefully you can see that. And that's 7. So my final answer to 16 49ths is, and I'll say equals 4/7. There's my answer. Okay, and it is the same, absolutely the same with those cube roots. So if I have a cube root of 8 125/125, the cube root I'm looking for, what is the cube root of 8 over the cube root of 125? And hopefully you can see it as what numbers times itself 3 times, or what number to the third power gives me 8, and you know it's 2. And what number to the third power gives me 125? My next cube is 5. Because 5 times 5 is 25, times 5 is 125, 2 times 2 is 4, times 2 equals 8. So therefore, the cube root of 8 over 25 equals my 2/5. Okay? That's how we're going to deal with our cube roots.